Step. We're going to have Ian Ward, who's an independent developer and wrote the Urwid library, talking about cool stuff that you can do with Urwid.
Hey, thank you. I'm going to repeat part of that for the camera. My name is Ian Ward, and I'm an independent developer. If you've got interesting projects, get a hold of me. Okay, today I've got a fairly light presentation. I'm going to be presenting a number of applications that use the Urwid console user interface library for Python. First up is bpython, and now technically bpython is not an Urwid application. If you run it the normal way, it will just use the turses module. However, there is a backend that was developed for Urwid, so I'll use this as an excuse to include this in my presentation because it's such a great program. I just want to show it off. So bpython looks like a lot like the regular interpreter, except that you get syntax highlighting and suggestions for completion while you type. This works for keywords, for names, for module names. And if you want to use any of the suggestions, you can just press tab while you're typing, and the text that you select will automatically get replaced. It also brings up docstrings while you're typing. So when you enter a function or method or creating a new object, you get the description of what it is you're about to call, including highlighting exactly which parameter it is you're entering at the time. It's got smart indentation, which most of us are used to in our editors, which is a very handy feature. If you open a block, it will indent 4 spaces for you, and so on. When you hit enter on a line that's blank, it will automatically unindent. So this is, as I'm sure many of you are aware, a whole lot easier than the regular Python interpreter. The auto-completion works for all the names that are currently visible, so including this class that I just created, it can automatically suggest that one. And errors are helpfully presented to you in bright red, just to let you know when you mess up, which is a lot for me. So with the regular Python interpreter, if I was in this kind of a situation where I had hand-rolled a little class or something more than a few lines, the only way that I've found to fix it would be to hit the up arrow a whole bunch of times and hit enter and then try to keep doing that just right. bpython has a much better option. You can just press Control-R to go back in history, and you just show up in the middle of your class, type some new code, and the class is fixed. So this is something that's very nice. And it also works on variables. So if I've just lost this object, maybe I spent a whole bunch of time creating this big query set or something, and I blew it away accidentally, I can just rewind back to the statement where I'd overwritten it, and there it is. So very nice, very nice features for an interactive interpreter. Next up is videotop. Now, this is a very simple little program that does its job very, very well. It's for downloading YouTube videos, basically, or also streaming them. The interface starts off very sparse, but it's got all the information that you need. You just press you type :S, and then enter what it is you're searching for. So if I search for some videos, this goes out and uses the GData API to pull down all the matching videos based on the search terms. You can then use the cursor keys to select videos that you want, and enter starts downloading. Now, this is done in a sub-process, so I can then select another video and start downloading another video as well. And this is really handy because, of course, if anybody's done this, you know that Google limits the speed that you can download any individual video. So this is a great way to get a bunch of them if you're going offline for a while. You can also stream directly from here. You press another key, it'll open MPlayer and stream from this interface. And when you quit, after you've downloaded, you've got a separate window that shows you all the downloads that it's aware of, and you can play them from there. But then when you quit, everything is saved, including all of the current download state. So you can immediately go back, search again, and resume your download without any extra effort. Next is alot, which is a mail user agent based on NotMuch. Some of you might be familiar with NotMuch. It's a tag-based organization for your email. So instead of folders like you might use in an IMAP client, it's just tags that's on the email that determines what you're looking at. This is going to be familiar for anybody that uses Gmail and searching through your Gmail folders. So NotMuch itself, as the name suggests, is not much of a mail client. It's actually just a command line client. You put your searches in at the command line, get results, and repeat. So this is an interface that shows you all the results of a particular search. The default one shows you everything in the inbox that hasn't been deleted in a nice, easy-to-list format. And the way that you move around is by entering new search terms. So it's not folders. Again, you just specify what email you're interested in. If I select one of my threads here that has a few messages, the first thing that happens is that it expands all the messages in that thread. And then I could use this to scroll up and down just with the page up, page down keys to see everything. Or I can press Shift-C to collapse everything into this handy little tree and quickly jump to the particular message that I'm interested in. From this screen, you can also do all the usual things you'd expect. You can forward, you can reply, you can mark individual messages. You can pipe your messages to external programs or bounce them, so forwarding without all the extra headers, which seems to have been forgotten in recent email history. You can also select individual messages and expand them with Enter. So it's a really nice way to browse a particularly long thread and get around all from the from the console. Okay, Turses is a Twitter client, and I might not do the best job of this because I haven't figured out the Twitter yet, but I'll try to show it off. Turses starts off with, after you do all the usual authentication, you punch the key in, it steps you through that process, with a screen of all of the, latest tweets that you have yet to read. You use the HJKL keys, like you might be familiar with from VI, to move around through messages. And you'll see they also make some clever use of Unicode. They've got a recycle symbol that appears on tweets that are retweets. And they've got syntax highlighting for different people's names, hashtags, and URLs. Across the top, you'll see that there's also tabs in this interface. And the default tabs will have mentions and things that have been sent directly to you. You move back and forth between those with the H and L keys. But you can also display multiple tabs at the same time. And this will just display adjacent tabs on the same screen in columns. So you can have 2 or 3, if you like, particular views that you use a lot and have them on the screen and updating for you. So all of the standard commands are there, the things that if you're following users, retweeting, all the stuff that you would expect, except that, of course, being a console interface, it's all keyboard driven. So you're not reaching for buttons to click. So if you learn it, you can get a lot faster with it. Searching is one way to open a new tab. So if I see what the latest action in the Ninja Turtle scene is, I can do that. That shows up as a new tab up there, and I switch, and there it is. T is used to tweet, and that interface comes with the standard count of the characters that you entered so far. The next program here or actually set of packages, is called hachoir. Hachoir is a set of packages designed for manipulating and viewing a number of binary formats. It supports, I believe, between 30 and 40 different formats, including a number of video formats, a number of compression formats, and image formats. And according to the developers, the Urwid interface is the sexiest one available if you're just browsing around. So this is what it looks like if I was to open a JPEG. It starts with all of the byte offsets for each chunk of data at the left in a handy tree. You can go down and expand any particular piece of it that you want to dig into and see the values for. All of the numbers that are displayed default to a human-friendly mode, like the 39.2 kilobytes at the top of the screen there. You can switch that off with the H key to get exact numbers. And you can just keep digging in and digging in. And the nice thing about this set of libraries is that they're lazy, so it'll only do the amount of work that it needs to actually get the information that you want. It doesn't have to parse the whole file, so it comes up right away. And you can keep digging in and digging in. You can see, I believe the smallest format it supports is fields down to an individual bit. Here we've got some fields that are 4 bits each, and so there's a 0.4 distance into this file. So that's the hachoir-urwid interface. The library itself, the hachoir parser and hachoir metadata, are used by certain media libraries or media management libraries to pull out metadata from media files without needing the particular libraries for parsing those that might be written in C and that you might not trust as much as Python code that could fail in a safer way. Okay, this one is mine. Speedometer is a little application that I actually wrote sort of to demo what the library could do. And if this wasn't screenshots and it was running, or actually here, it is running. There it is. It will steadily march along and update with the rate of data that's going across any particular interfaces that you're interested in on your machine, as well as rate of data being received in a file. So you can point it at a file download and you can see exactly how fast it's coming down. If you tell it how big the file is supposed to be, it'll also tell you when it would expect it to arrive and give you a progress bar. On the command line, you can customize exactly how many of these graphs appear, how they're divided. I've got them one on top of the other, but you can have columns of them as well. You can also specify the scale and on the left-hand side. So that's a recording of me testing my cable connection with speed test. The other one really nice feature of the Urwid library is that when you're writing an application using it, you almost never write any code that handles resizing. You're working with widgets and containers and decorations that all have an understanding of what they're supposed to do given the amount of size they have. So this program, will just continue on. Here, the data is being displayed, and if at the same time I'm dragging the window, it'll just keep on going. So there's a graph widget that just knows how to scale itself into whatever space is available, and nothing special has to be written on, from the developer's point of view. The last one here that I'm going to present, and also my favorite, is pudb, which I wish I had found a lot earlier. It starts off with a very friendly welcome message and tells you pudb is a full-screen console-based visual debugger for Python. You can scroll down to see the latest changes. The first time that you run the program, it enters into the preferences window. You can set whether you'd like line numbers displayed. You can choose which of the shells you'd like to use, including the bpython, which I mentioned earlier. To keep in line with the rest of the programs I've presented, I'm going to switch to a dark background here. Not that I have a lot against the sort of turbo vision colors that it starts with, just nice to be consistent. And it has all of the usual commands that you would expect from a debugger: step over, step into, breakpoints, stack view, except that of course those things are in windows on the side of the screen that you can manipulate or look through a lot more easily, I find, than just with this basic PDB. So this is a little basic test program that is a failed version of a sum function that takes the last two elements in a list, adds them together, and keeps doing that until it gives you a value. But of course, there's a bug in it. So I run it. The stack explodes. And there's a big trace back in this window. I can scroll down to see everything that the user would see. But better than that, pudb puts me into this post-mortem mode. I've still got all the information about the stack frame and everything that's going on. So I'm just going to switch over to the stack window here, go down a few stack frames, and take a look at what's in this values variable at the current time. So that doesn't look quite right. I was trying to add 5, 6, 7. We've got a number in here that's far too large. So I'll just expand my view a little bit, have a look at a line that I find suspicious, and so I'll take a look at that line where I am actually adding things. If I press Q, this brings up a menu that gives me the option to restart the program without exiting, and I'll move down to this line, and I'll set a temporary breakpoint by pressing T. This sets a breakpoint, continues execution, and then removes it as soon as it arrives there. So it's sort of like teleporting straight to that line. So I arrive there, and sure enough, I take a look at my values, and it has exactly what I expect, the values as they were passed in. Then I switch back to my code and I step once more. And this is another handy feature in pudb. When you're about to return a value, it doesn't return immediately. It gives you one last chance to see what the value is being returned to the function that called it, which is sometimes tricky to find when it's a complicated call chain. So I'll have a look at this, and I see, sure enough, okay, the last two numbers were added correctly, but I just forgot to take the 6 off the list. Okay. Now, most debugging situations aren't going to be 2 little functions and 10 lines of code. You're going to have lots of modules to deal with. So pudb handles this very well as well. The module selection interface here, you press M, and then you can just start typing, and it will auto-complete to all of the modules that it can see that you can currently import. And then you can just select the one that you wanted to open up. Or if it doesn't know about something, you can force it to import from here. If I scroll down to the bottom, or scroll down a little bit, and this time I'm going to set a real breakpoint just so you can see what that interface looks like. I jump over to the breakpoint window and open it up. You see you've got the option to enable or disable the individual breakpoint. You can also jump to a location of the breakpoint. So if you've got a really complicated problem, you can use these like save locations to jump back and forth between. And you can enter a Python expression as a condition that will determine whether or not it's actually going to stop this time. So the last thing in pudb here is that you can always drop into an interactive interpreter. And this is really sort of the catch-all. Anything that's difficult to do by adding a watch variable or looking through the code, you've got free reign here. You've got all of the local variables in the current stack frame. You can print them, you can pass them to other things, and do whatever else you need to do. Okay, that's my presentation. Time for questions? The questions? Yeah.
So, with all modern GUIs, why do you think people still use console applications?
Well, it's you're almost guaranteed that the person writing the program is similar-minded to you, and meaning that they like an interface that they can use the keyboard, and it's very likely that you're going to be able to learn it and get fast at it. That might be part of it. I started working on the library just because I found lots of interesting problems to solve in it. There were lots of very hard things that are generally most people wouldn't be interested in, but I just wanted to see if I could crack them. And yeah, I like console applications that have good interfaces, that are responsive, that resize right away, and that behave generally well. So I was trying to encourage that. And I use console or applications on the console all the time. I probably have more GNOME terminals or X terminal open than any other window at any given time. Oh yeah, sorry. The question, the question was, why do people still use these things in this day and age, since GUIs are so wonderful, approximately, right?
I used to use dialog tool for bash, and at one point I tried to rewrite all the code I wrote in dialog in Python, and when I tried to use urwid, it was quite a bit more complicated than dialog. Is there any library that just lets you create a couple of GUI windows and that's it?
Right. So there is actually a dialog example program that comes along with Urwid. I just can't remember if there's, so these are screenshots of the dialog example program. So you could just copy that code if you wanted this sort of thing. I admit I was shooting for something a lot like lower level than dialog, and I think there are some libraries that do just this sort of thing a lot simpler. So you can take a look. I think there's a link to one of them from the Urwid website as well. But if you're doing this sort of thing, yes, I admit, this wasn't really the goal. I mean, I think I was trying to serve people that are coming up with sort of the next Vim and the next W3M and that sort of thing, more than the simple kind of dialog interface, even though I admit a lot of people are looking for exactly this.
Yeah, okay. I don't think it was available a few years ago, but now I'm definitely going to check it out.
Sure, yeah.
What's your development environment look like? Do you use a graphical IDE or?
So the question is whether I use a graphical IDE, and no, I don't. I use Vim. I use lots of terminals. So yes, I'm certainly biased that way. Okay, that's it.
Step. We're going to have Ian Ward, who's an independent developer and wrote the Urwid library, talking about cool stuff that you can do with Urwid.
Okay, thank you. I'm going to repeat part of that for the camera. My name is Ian Ward, and I'm an independent developer. If you've got interesting projects, get a hold of me. Okay, today I've got a fairly light presentation. It also brings up doc strings while you're typing. So when you enter a function or method or creating a new object, you get the description of what it is you're about to call, including highlighting exactly which parameter it is you're entering at the time. It's got smart indentation, which most of us are used to in our editors, which is a very handy feature. If you open a block, it will indent 4 spaces for you, and so on. I just want to show it off. So bpython looks a lot like the regular interpreter, except that you get syntax highlighting and suggestions for completion while you type. This works for keywords, for names, for module names. And if you want to use any of the suggestions, you can just press Tab while you're typing, and the text that you select will automatically get replaced. And I'm going to be presenting a number of applications that use the Urwid console user interface library for Python. First up is bpython, and now technically bpython is not an Urwid application. If you run it the normal way, it will just use the curses module. However, there is a backend that was developed for Urwid, so I'll use this as an excuse to include this in my presentation because it's such a great program. You hit enter on a line that's blank, it will automatically unindent. So this is, as I'm sure many of you are aware, a whole lot easier than the regular Python interpreter. The auto-completion works for all the names that are currently visible, so including this class that I just created, it can automatically suggest that one. And errors are helpfully presented to you in bright red, just to let you know when you mess up, which is a lot for me. So with